Hey guys, welcome to this video series about authoritative networking in Unity. We will make a framework which we can use in different games to make use of authoritative networking, which includes client-side prediction as well. So if you look at this three screens, we have the host here on top, and we have two clients connected. And basically the principle is when I move my own player on the my client on the left side, I will send the inputs to the server, which will process my movement, and then it will send back the positions to all the clients. It will also send back its positions to the owner of the capsule, of the player in this case, and then verifies all the positions he did, and if they don't match, we're going to snap it back. So you can prevent cheating a little bit this way. We won't be covering every detail to prevent everything, but we will be a little bit more of a challenge for any hacker of your game. Now, if we look at how it moves, a little disclaimer: because of my recording software, it's a little bit more jumpier than it is without recording software. It's very smooth. So if I move the client, I'm controlling the right side, you can actually see it's smooth on my end, and a little bit later it gets moved on the clients too, and even earlier it gets moved on the server. This is because we are sending the inputs towards the server, and then this will transmit it to all the clients. Now we will make a little slider where you can easily control how fast the network updates are being sent. So you have a little less lag. I believe I have like half a second delay right now. So this will drastically reduce the number of packages sent at the time. But if you drop it down like 10 messages a second, it will be, of course, much more responsive. And also you might use that for when you get closer to each other or something like that. But well, yeah, you can see it simply follows around. It's a little bit late, like I said, but it will follow it around and eventually move into position. Now let's move the left side here, and then you can see it works exactly the same. Okay, well, that's it. Let's get started. Okay, let's get started with a little playing field. So let's first create a plane. Let's scale this up a little bit, 1515. Let's create a folder for some materials. And then we're going to create a material for the floor. There we go. And let's change the color a little bit. Oops, switch to scene view, of course. There we go. Let's see, where's the camera? Right there. So this is where we are looking. And maybe let's make it a little bit more dark. Something like this. And then let's create a player. So let's create a new capsule. Reset it to center and raise it so it's like so. Let's disable the collider for now. And let's make a material for this too. Player. And let's change this to a different color. Maybe a greenish. Like this. And let's raise the camera, or at least change the camera, so we have a little playing field. So what I like to do is just simply move the camera, the scene view, like this, and make sure with the camera selected, hit Control Shift and F, which will copy over the transforms rotation and position. So now we can see this is our playing field. Okay, what we are going to do, we are going to make a small reusable part which we can use to know when we want to send and receive packages and do something with it, but we are going to implement it using the UNet. So it's Unity for a networking solution from Unity, but you are able to change it to Photon or anything else if you want, but that's not covered in this video. Okay, so let's first change this capsule to player. Come on, player. And let's create a prefab out of it, like this, so we can spawn it from the networking. Let's create a new folder, scripts, and let's create a new C# script, and let's call this a player network. And we are going to assign this to our player. Now you saw I added it to the prefab, so it will automatically get added to the edit player here. Let's first create some movement. So let's add a character controller. Simple as that. Let's take a look here at the player. Like this, okay. Let's open this up. And I'm gonna zoom this in a little bit, so it's better to read. Okay, for you. Let's see. We are going to make some variables here, of course, for the speed. So we're gonna make a serializable field for move speed, and then we are making a new method here, void. Let's call this move. And because what we are going to do, we are going to add more stuff for networking here later, but first we're going to just let the player move. So the move will take a float for horizontal, and a float for vertical. So this will be your implementation when you are going to create something new, when we have finished the entire project. You can create like your player network, and then this is where you control the way movement is done. Okay, so then we just simply add, let's see, we need a controller reference. So let's make it here like a character controller. In our start, we're going to say controller equals to a get component character controller. We can say require component if you want, like this. Now when we are moving, we are simply going to say controller move, and then it's going to be a new factor 3, and then it will be a horizontal 0 and vertical. Just plain simple. And in our update, we can say move. Let's just give it a quick try here to see if we are going where we want to go. No. Oh yeah. Move. Of course, we need to add the input. So input get axis horizontal. I believe this is case sensitive, so make, if I'm right, make sure you have it as well. And a vertical input get axis vertical. Okay. Now let's see if this works. If we run it, there we go. So you can see it moves around. Yeah, nothing fancy at all, but still. Maybe it's a little bit too. Oh, we don't use the speed right now, so let's times move speed times move speed. So now it will stand still, so let's set it at 0.5, so it will be a little bit slower than we just had. There we go. Okay, So a player moves the way we want. Now let's show we apply this to our prefab. So what we are going to do, we are going to send these inputs to the server, and then we predict, or that's like a difficult word for just doing what we are doing right here. We are predicting what the outcome of the server will be. So basically we are just going to move the way we are here, and that is prediction is basically we assume the same result as we have on the server. Yeah. Okay. So this is basically prediction already. Well, not entirely. Let's first make sure that we got everything straight. We have a host, we have a client, and we have local players. Now, when you develop when you are working on multiplayer, it can be difficult to understand which one you're controlling when and how. I mean, if you're trying this and you only play as the host, it will be something different than when you also connect one client. But it will even be more different if you connect another client. So you have to make sure you got that straight and working. Now, also people say that networking is very difficult. Well, it is, but it's not very difficult. It's just different. It's a different approach, the way you have to handle things. Instead of just picking up an item, we are simply now often saying to the server, can I pick this up? Or the server picks it up and tells our player that I have picked something up. that's the way it works. Okay, and basically you are doing this because you are preventing cheaters. If you're only playing with your friends on a LAN, well, don't hassle going to authoritative networking if you don't need to. I mean, who cheats, Okay, so let's get it straight. So let's make we have an update method, but instead of simply saying move here, we are just going to make the move when we are the let's see, if we are the local player. Yeah, so let's make a public, or maybe it doesn't need to be public, so make it a local client update, or maybe a local player update, but local client update. And then we are going to say we are going to move. Yeah, and in our update we're going to say a local client update. Okay, let's see. This will do exactly the same. So now let's get started with networking. Let's first create a new script. Let's call this network packet controller. This will be we are going to derive from in-play network from this class, which will expose some features to us, or not features, but it will expose methods to us, which we can use to execute networking. And let's open it up. This one will inherit from network behavior, which is Unity's implementation of networking. Yeah, so, which will require Unity engine. Why don't I have? It happens to me a lot. No IntelliSense. Let's see if I open it up again, if that works. Probably needs to compile it first. Still nothing. No. Damn it. Sorry. Gonna restart Visual Studio here. Let's try it again using Unity engine. There it is. Unity engine networking, to make use of the networking part of Unity. And then we're going to say network behavior. Yeah. So if you are going to use Photon or anything, you can inherit here from the Photon network behavior, or whatever it's called. I don't quite remember. Okay, let's create two system serializables. So we want to create packages which we are going to send over. It's going to be a class package, public, and it's going to take a public float horizontal, public float vertical, and public float timestamp. So let's do the casing I usually do for every public method. Okay, so basically we are making a package here, this is what we are going to send. We're going to send a horizontal input, vertical input, and we're going to send the timestamp of the package. Now we are making it serializable, so we can serialize this to a package which we can transfer, because it will only Unity only allows you to send primitive types, and we want to send whatever we want, you know. It will take a little bit of more code to get this done, but it's well worth it, I think. So system serializable as well for a new class for receive package. So we are sending packages and we are receiving packages. Now the receiving packages will contain positions, yeah. So instead of using a vector 3, we are making a public float x, a public float y, public. Why am I always typing public wrong here? Public float z, and public float timestamp. Okay, so those are the two packages which we are sending over and which we are receiving from the server, or which get received. Now we are going to create a package manager which will manage our packages for us, and this server will, this class will be responsible for sending and receiving the packages itself. So we're going to make a new class here. There we go. This will be our network packet manager or something. Let's wait for it to compile. Okay, there we go. Open it up. Now we are not going to inherit from mono behavior here, because this will be something else. However, we are going to, this network packet will manage the package or the receive package. So we have to make sure that we are making a generic type to instantiate the network packet manager. And it sounds more difficult than it actually is. So if you look at the network packet manager, here we're going to say it will take a generic type where the type is a class. Now we are just simply saying it should be any class. We could also make an interface or another typed anything where our classes inherit from, but just do it like this. It should be okay. And let's get rid of these because they will never be called. And then we're going to make an event, system action, and this action will give us a byte array, because we are going to make an array of bytes from the package we are going to send. On require package transmit or something, transmit. Yeah. So when the network packet manager tells us we want to transmit a package, it will gonna raise this event, yeah, and we are going to subscribe to this event from our network packet controller to actually send it. Let's make a float, maybe private float for send speed. Let's first set it at 0.2. So it will be 0.2 seconds, every 0.2 seconds. But of course we're going to make a public variable for it as well to check if send speed is not less than 0.1, because we don't want to have it any faster, I think. Yeah, then we're going to say return m send speed equals to 0.1f, and otherwise we're going to return the send speed. And in our setter we're going to say m send speed equals to the value which is assigned to send speed. Okay, now let's we need something to make a new tick, so let's make a next tick, which will be the time when we want to send a new message. And then we're going to create a private list of our generic type. So whatever is passed in here, we're going to make a list out of it. Let's call this m packages. And in our public list, packages. There we go. In our getter, we're going to say if m packages equals to null, we're going to create a new, come on, m packages equals to a new list of our generic type, and then we're going to return the packages list. Come on, packages. Okay. Now, what we are going to do, we are going to queue packages which we receive. And we're gonna replay those packages, and we are going to add packages to the queue when we want to add packages. Yeah. So let's create a queue here, and this queue will be also filled with our object or generic type packages. Now a queue is like something like a list, but if you take one, it automatically gets removed from that list. So you can always take first in, first out, or whatever is first in queue. Let's make a void add package. This will again take a generic type. And then we can say our packages add package. Okay. Let's make a description for this. By the way, add package, maybe add a new package to the list T we would like to transmit soon. Okay. Next up will be our a method which will receive data from a byte array. So when we receive data, it will be a byte array. Data. We will take a byte array, bytes, and then we're going to say if receive packages equals to null, receive packages equals to a new queue of T, our generic type. So we are making sure that we have a queue here. Let's process any data received. So now we have received packages, and now we are going to we need to read the bytes. Yeah. We want to read the bytes and cast this back to whatever it was. So we're gonna deserialize the bytes. So let's create a list of our generic type. Let's call this read bytes. It will take a byte array and bytes, and this will, let's use a binary formatter, I believe, which will require us to add this using statement. By the way, I used Shift-Alt F10 and press enter, it will add the using statement. So a binary formatter equals to a new formatter. And then we're going to say using memory stream Again, Shift Alt F10 to use the system IO. This will our memory stream equals to a new memory stream. There we go. Now we are making a using statement, so it will automatically dispose the memory stream when we are outside of the using statement again. And now we are simply going to write the bytes in the first index of our memory, and we're gonna for the number of bytes length. So now we are writing the entire byte array to the memory stream, and then we're gonna set the cursor to the first point. Will be begin. So we make sure we move the cursor to the first part of our memory stream, and then we're gonna return let's see, a formatter deserialize. So we are deserializing the memory stream, but we want to format it in our list of T, because we know we are having this list. So like this. So basically we are reading bytes, adding it to a memory stream, and then we're going to deserialize the entire stream to a list of our generic type. So when we are receiving data here, we could say our array of packages which we are receiving equals to read bytes and then our bytes, and then we're going to say to array. So now we have our list of generic types of our packages which we have received, and now we can loop through it. So again, let's add a snippet, type 4, and then press stop twice. For int y is 0, I is less than our packages length. So we want to loop through all the packages, and then we are going to say here receive packages NQ. So this will add a package to the queue, packages y. There we go. So now we are adding the packages to our queue. All right. Now let's also make the part where we are when we are ticking the how can I say it best? We have a time here for a send speed, and then every time we want to tick, like the when we want to add a new tick to our send speed. So when it equals to 1, or I believe bigger than 1, we can transmit packages. A lot of words for this simple method here, and I'm probably even explaining it wrong. But here's our tick, and we are from our update methods in our network packet controller. We are calling this tick. So every fixed update or update you want, we are ticking, and then it will increase our time send speed. Yeah. So our next tick will be we are going to add 1, and we're going to divide this by our send speed times the time fixed delta time. I'm using fixed delta time, however this is frame rate independent, so you can probably use a different value here too, but I'm just going to use this one, because if someone with a higher frame rate will obviously send more packages then. Yeah. Now if next tick, if this is greater than 1 and our packages count is greater than 0, we want to transmit packages. Yeah, so every tick we are going to add to the tick, and if this tick gets higher than 1 and we have packages we want to send, we are sending the package. Yeah. So then we're going to say first next tick will be 0, so we preset it, otherwise it won't be sent again, and then we're going to check if the onRequire package transmit is even used, because otherwise nothing will happen. And then we can say our bytes will be our bytes, and then we need to create a byte array from our package. This will be something like here as well, but this is a little bit easier. Let's like byte and create bytes. So we are going to create bytes from our packages. Again, the binary formatter. Is new binary formatter, and then we are going to make a using statement of the memory stream again. Or not using statement, but memory stream. New memory stream, and then we are going to formatter serialize it. So we are going to serialize the packages to the memory stream, and then we're going to simply return the memory stream to array. So now we can here say our packages will be create bytes. Read bytes, this is wrong. Byte array bytes equals to create bytes. So we are creating bytes of our packages, and then we are able to let's see, take here. Now we can say our packages can be cleared. So this will clear the entire packages list again, so it will get new packages. And then let's see here. Yeah, we need to call this one, and this will take the bytes we have just created here. Okay, so first we're going to create the bytes, we're going to clear the packages, and then we're going to raise the event that we require to transmit the packages. Yeah. So this is pretty much the entire script. Let's go through it one more time. So we are having a packet manager which accepts a generic type of T, which should be a class, and this will be our packages and receive packages. We're going to make two network packet managers. Then we have an event which will get raised when we require to transmit our packages. We have a send speed. We have the packages, which will hold all the packages we want to transmit. We have a queue with packages which we have received, a method to add packages to our package. This one could probably be private, but okay. Then we have our receive data, a public method which can accept a byte array and will read those bytes and transform this to an array of our package type or generic type, and then we're going to queue this to our received packages. And so we can process them later on. And then we have our tick method, which will raise our required packet transmit when the time is there. Yeah? And our two methods to create bytes and to read bytes. Now I'm aware that this is can be a little bit more slow, but I think we can use this for now. You know, unless we run into problems later on, I don't think we need to change. We don't have to change this. Okay, so let's head back over to our packet controller, and let's make two variables for our new network packet manager. Network packet manager, and you can see it accepts a type of a class, and the first one will be our package. This one. Now let's call this packet manager, package manager, packets, whatever. Even private, and then we're going to say a public network packet manager of package manager. This will get. And then we're going to check if the packet manager, if this is null, we're going to make sure that it's something, a new network packet manager of the type with the package generic type. Let's check if I'm still recording. Yeah, otherwise it will be a little bit silly. Packet manager, and then we're going to say if is local player, which comes from our network monitoring behavior. Oops. So if we are the local player, we want to transmit. And then we're going to add a new method here. Let's call this transmit package to server. Yeah. Okay, so only if we are the local player we want to transmit. Yeah, all the others we don't want to require anything at all. We want to transmit anything at all. So then when we are done here, we're gonna return the packet manager. Okay, now this is the method which will actually transmit it. But before we do it, let's copy the entire part of our network packet manager over. And let's add the other class, the receive package here. There we go. And let's call this mServer packet manager. And make sure we change everything. There we go. Now not when we are the local player, but only if we are the server. So if we are the server, we want to transmit packages to the clients, and otherwise we won't. And if we are the packet manager and we are a local player, we want to transmit. So every dummy or proxy player which isn't controlled by you and or the server doesn't do anything at all. Yeah? Okay, so now we have our transmit package to server, which is our byte array of data we want to transmit. Now I'm going to use commands and RPCs to get these packages over. Now that's the cool part. We have added our package classes and our receive packages. We converted it to bytes, and we can easily send these with RPCs. Yeah. So let's first make a command. Now a command can only be invoked on the server, or will be invoked on the server. So then we can say command transmit packages. Now this is important for Unity to have this exact name. If you have a command, a method decorated by the command attribute, you need to start with cmd and then whatever you want to use. Okay, now this will take the byte array data. Let's call this data. So when we are calling this method, it will be a call to the server. Yeah. So in our transmit package to server, we're gonna say cmd bytes. Yeah. Now this when this is run on the server, it gets automatically triggered on your server. Yeah. And then we are going to say here packet manager packet receive data. So this is run on the local player, and this is run on the server. Yeah. So then we are going to add the packages received to the object. Now we have another client RPC, and then it's going to see RPC receive data on client. Now I tend to use these descriptive names all the time, so I can easily see where is this called. Receive data on client. Yeah, okay. Data, and this will have our server packet manager receive data. So server package manager is the data which we receive from the server. Packet manager is what we send to the server. Yeah. So what is run on the server. Okay. Let's see, what were we? Yeah, wrong here. Of course, we are not transmitting packages to server here when we are doing this, but we want to transmit it to the other clients on the server. So we're going to make a new method here, and this will be our transmit to clients. Copy this over. And this will send an RPC to all the clients. Yeah, an RPC is called, like remote procedure call is called on the client's game objects. So when the server requires to transmit packages, it will transmit it to its client and it will send the data there, and then the client will get triggered the receive data on client and will add the data to his server package manager. Yeah. Okay. Now, to continue, we need to tick these packet managers, like I said, to increase the time. So we're going to use a public virtual void fix update. Again, I'm using fix update, which is probably not the best, but I'm not really sure which one is better to use right now. But now we're going to say the packet manager tick, and also our server packet manager. Server tick. So we are marking this virtual, so we can use it still in the other class where we derived this one from. Let's see, this will be our play network, which will derive from our network packet controller. Yeah. So because we marked the fix update virtual, we can still use it here in our play network. Okay. Let's see. I think let's go this over one more time in our packet manager here. I'm sorry, in the packet controller. So the packet controller inherits from network behavior. If you want to use photon, you should override photon, implement photon here, and make whatever use you want to transmit or receive your data from your clients, or from your server and to your client, to the server and from your server. But we are creating two packages, two packet manager, one for stuff we want to send and one for stuff we are receiving. And well, basically we are sending the inputs and we are always receiving positions from the server. So we create two packet managers here, one for the server, one for the clients. Transmit packages to server, transmit to local clients the events. And when these events are called, we are actually sending these over. This is actually the high level networking part here. And in our fixed update, we are ticking both the packet manager and the server packet manager, package manager. Okay, let's head over to the player network. So we are inheriting from the, or deriving from the network package controller. So we have access to its properties. Yeah. So let's see, in our start method here, we are going to let's see, we are going to set the network speed. Yeah, that's what we're going to do. So we create a serialized field, which will be a range from 0.1f to 1. So we can go as low as 0.1 messages per second until 1 message per second. So we are gathering inputs for this time and then we are transmitting them. Then we're going to say float the network send rate equals to, let's set it by default at 0.5, which is pretty high. I mean, pretty slow actually. Okay, and now we want to make sure we have predicted packages. So we are creating a list of receive package, which comes from our here, from our packet controller. We keep a list of our received packages, Let's call this predicted packages. Now, received packages are our predicted packages, so this will hold whatever we have done, you know. So it's not actually what we are receiving, but we are simply, when we are in the local client update, we are, let's first make some checks here. Only do this if we are a local player. Is local player. This gets called from. This is available from the network packet controller, which derives from the network monitoring behavior. Yeah. So if we are not the local player, we are going to return here. And then we're gonna make sure we only transmit data if we are actually pressing buttons. Yeah. So if input get access horizontal. If this not equals null or 0, or input get access vertical not equals 0. So if any of these is 1, are we missing one here? No, like this. So then we are, let's get a time step here. Time step is the time.time. So we are just getting the current time. And then we're gonna add a package to the package manager. Yeah. Packet manager. We're gonna add a package, and this will be a new package. And it's going to add the horizontal, and it's going to add the vertical. Note that we are only sending the inputs. We are not multiplying it by time or by the speed, because we don't want the clients to send how fast they are moving. We just want to send, I'm pressing this button, you know. And then we are going to say the timestamp equals to the timestamp. Whatever. Okay, so now we have added a package. And let's first don't do any prediction. Let's filter this out first. First, we are going to try to do this without prediction. So then you can notice that if you're pressing the button, it will first go to the server, then the results would get back, and then your player will move. So it will be a little bit laggy response. But then we are going to add prediction, and then you will see that it will be faster. Immediately responds. Okay. Let's see. Is there anything else we want to do? Yeah. So we have our move method here. Let's move this a little bit up. There we go. Now we probably need something for the server too, because this is both run on the server and on the client. So now if we are, let's make a server update here. So let's, we have an update, and we have also our server update. Server update. There we go, and let's create a new method here. Void server update. Of course, we only want to run this if we are actually the server. If is server. If we are not the server, we want to return. Now, I always more like the dedicated server feature, so I don't want to do this if we are a local player too. So the server won't be able to actually move. Yeah, only remote clients can move. So when we are starting the game, we are setting up a host which will do nothing except receive inputs and transmit those inputs. Yeah? And when we are the server update, we are getting the packages package data is packet manager. Oh yeah, we of course need something to receive this data. So if we head over to our, let's see, packet manager here, we also need the next data which we are receiving. So if we look at the method here, below the tick, let's create a new public of our generic type, get next data received, which will basically pulls out the next in line package we have received. So if received packages equals to null, or received packages count equals to 0, return default t, which will be null. Yeah. Otherwise, we're going to return receive packages, and then we're going to say dequeue. This will take the first one out of the list and then remove it, yeah, and then return it, so we can return it. So now we have to get next data received. So in every server update, we are going to check for data, yeah, for package data. Now, yeah. Now, with this data, which is basically the input from our remote player, we want to actually move the transform on the. Let's first check the package data. If this is null, return. So if we have package data, we have received something from this player. So then we want to move this player the amount that he the package which he pressed at the button. So then we're going to say move package data horizontal times the move speed. So this is run on the server, and also the package data vertical times the move speed. Now we are moving. So we are moving. Then we need to check if we have actually changed positions. So let's create a new variable here, factor 3 last position. And then here, after we have moved, we are going to check if the transform's position, if this equals to our last position, just return. We don't want to do anything else because we haven't changed positions. Otherwise, we're going to say last position equals to a transform's position. All right, and then we're going to add the package of our position to the server package. Yeah, so then we're going to say server packages manager, add package, new receive package. There we go, and we're going to add the x, which will be transforms position x, y transform position y, and the z will be transforms position z, and our timestamp will be the package data timestamp. So we are adding the same timestamp from the package we received. This will be sent back, so we can use this to correct the timestamp. I mean, we are sending a package with a timestamp with a certain movement, which has a certain result. We're going to do that the same thing on the server, and then we're going to transmit that back to the local player. Then if these don't match within a certain threshold, we're going to snap the player to that position of which we received from the server. So basically, if we collide to something on the server and we haven't collided locally, we still get to the position where we have collided, you know, or where we are moving after colliding. All right. Okay, so now the next thing is we need to move our player. Like I said, we're not going to do prediction right now. We're going to add that later on in this video. So first, if we look at the code. We in the update method of our player, we are gathering their inputs, transmitting these to our adding these to the package manager, and this will take care of transmitting and receiving our data. So now we are not moving our player at all if we are going to run this. So we need another method which we will use for moving remote clients. But this will also include our local player checks. Yeah. So let's create a public void remote client update. Then we're going to say if we are the server, return. We don't want to do this here. So, and then in our update, local client server update, remote client update. Yeah, I don't think the order is very important, but we're going to keep it like this. So back to this method here. So first we're going to check if there is data. Data is from a server package manager. We are going to get next data received. So this will check the next one in. This will get the next data in line from whatever we have received from the server. Yeah. So then we're going to check if data equals to null. Return. We have no data. We are not doing anything. And then we're going to check if we are the local player. No, wait. First not. First we are going to assume that we are or the local player or even the remote players. So then we're going to simply say transforms position equals to data, new factor 3, data x, data y, data z. So this will simply remove, set our player's position to whatever we have received from the server. Yeah. Okay, let's get back to Unity. Let's check this here first a little bit. If I see any obvious mistakes. So far, nothing. Okay, so now is the most difficult part in multiplayer game, which is testing. I mean, it's tedious to do it all the time, so be warned about that. Okay, let's first build. If you press Control B and you just say build and run. We first need to remove this player. So we're going to make sure it's applied, and then we remove it. But there's one more thing. We need a network manager. So let's create a new empty game object. Let's rename this to a network manager, and then we're gonna reset this for sake. Network HUD or something. Network manager HUD. Yeah. Then we have a player. We're gonna add the network identity. To it, and then we're going to say this is local player authority, and then our network manager, we're gonna simply automatically spawn our players. So then we're gonna drag the player to the player prefab and then just keep it like this. I think this should do it. Let's build and run. Network out. Should be an H, but who cares? So we need at least 2 clients to see actually what we have done. But first we're going to check if this actually works. So first I'm going to run the game, then we're going to host on the server, and then we're going to client on this one. There we go. Okay, so you can see we are moving. So if I'm pressing up, and you can feel it if it's working. It takes a little while before it moves. Yeah. And this is because we are first. You can see if you just press it will first move on the server, and then it will move on your own view. Feels laggy, and we want to add prediction, but it works smooth. Now let's add a new client here. Let's do it again. press Control B, it will build a new client. Play. Another one, Control B. But I think if it's already running, we're not using the send rate, so it's 0.1. Let's see. We should open this, I think, in Explorer here. Run this as well, and then start a server. Should be in. Damn it! Did we lose the scene here? Yeah. Sigh. Okay. I need to create a new scene. I'll be right back. All right, I'm back again. Let's save this scene as a test map. Now I lost the scene because I compiled when the game was already running, and then it fails. Okay. So I've saved it. Let's hit Control B to build and run. Hit play. Run it here too, which is the same. And then start Unity, which will be the host. Again, I cannot move here. You can try it. It won't. Hit the client. We still have the lag, no prediction, but if we hit client, you can see the other client is automatically synchronized at the right position, and we are moving. Now let's open up the other client here. Then you can see we are moving. Yeah, okay. Well, if you are here already, it should be quite nice for you, I guess. Okay, let's stop. And now add client-side prediction here. One more thing we haven't added, let's see the player here, the network send rate. We still need to add this to our to the script because we haven't. We have a method here, but we don't assign it to the to our packet managers. So to do that, let's go to our start and then say packet manager. Get manager send speed equals to network send speed network send rate. Now you also have a network send interval here, but we are not using this. This is used when you are using serialize those scripts you get from what was it called on network serialize view or something. I'm not using that. I'm only using RPCs here. There's not so don't forget, not only for the packet manager but also for the server packet manager. Okay, now predictions. Prediction, like I said in the start, is nothing more than just running the simulation or the game just like you would if you are not in a network environment, but you are predicting what the outcome will be on the server. And then when the server gets back, we just simply match those. And if they fail, or if they are like too far away from each other, we simply snap the player to that position and then continue from there on. Okay, so that way we can prevent players from moving to positions by hijacking our code or reverse engineering our code, and then move around, because we are not using the client authority as in I am here. No, we are using server authority. Yeah. So let's create a predicted packages, which we created on line 17, and let's instantiate it as a new list of a receive package. And then let's scroll down to our local client update. So right here within the, if we are in the if statement of the movement, then we're going to check if prediction, we need a variable here, serialized field, bool is prediction enabled. There we go. Then we say if prediction is enabled, we are going to actually move the way we did before, including the speed, whatever. We are trusting the client here to do whatever he wants to do. And then we are going to add the predicted packages, add new receive package. Now, another disclaimer, I'm not claiming that this is completely hack proof or anything, or the ultimate solution, because it's not. Okay, time step. Now what we are going to do, we are going to create a fake, or how you can call it, receive packages. So we are adding the time step, which we created here, which was the same of our package here, which had our input and vertical, horizontal and vertical input. So we are going to create a time step here, and we're going to add the x transforms position x, y transforms position y, and our z transforms position z. Yeah. As in, this should be the same as which we are going to receive from the server. If they don't match, we did something else or something changed, and of course there will be, because the simulations aren't entirely the same on every machine, because of so many what if not reasons. We need to have a little threshold to only move if it's larger than that, and otherwise we can assume, well, it's okay, we're going to ignore it. But still, so now we are moving, but if we would run this, the remote client update would simply overrule us by this. So this will give us effects which aren't what we want. I'm gonna show you. Control B to build and run. Play here and run here. Host here, client here. Now, as you can see, if you're moving now, it's jiggery all over, because it's constantly correcting us with first it's moving, then it receives from the server, pushes back, whatever, we don't want it. Okay, so it happens here. So in our remote client update, we want to check if we are the local player, and we also want to do this only if prediction is enabled. There we go. So if prediction is enabled, which we are going to set here right away, we are still at 0.5, so it's sending only every half second with the for minimum. So if we are a local player and we are predicting, then we are going to do something, and otherwise we're going to do what we did before. So if we are the local player and we are not predicting, we are simply using this. And if we are a local player and we are predicting, we are doing this part. And what we're going to do here is we're gonna let's check the, let's add a variable here for a float next correct time. No. I don't think we need that here. Let's get rid of this here first. Let's go back to remote client update here. Then we're gonna say here if no. Let's get the package here. So far transmitted package. So we are receiving data. Then we're gonna get the predicted package. Let's use a link here. So I think I can simply type it and then Shift Alt F10. Then we make a user statement of link here, system.link. And then we're gonna say here, let's where x timestamp equals to data timestamp, first or default. So we are getting now the same package from the same timestamp which we received from our predicted packages. Yeah. So then we say if transmitted package equals to null, well, we are now returning, but you should maybe do something here. Yeah. If this happens a lot or something like that. Let's create a correction distance. That's what I wanted to do. Float correction threshold. So this basically will we are going to check if the positions are too much apart. If they are bigger than our threshold, we're going to snap the player to that location from the server. So if factor 3 distance new factor 3, and then we need let's see, the transmitted package X, transmitted package Y, transmitted package Z. If this we're going to compare this to the factor 3 of our data X, data Y, data Z. Yeah. If this is greater than our correction threshold, if we exceed the threshold distance, then we're gonna snap to received location. Transform position. Oops, transform position equals to the data. No, I'm sorry. The new factor 3 data X, data Y, data Z. Okay, something like this. This probably requires way more work, but this is where you can do it. And then we're going to clear out the old predictions, because if we have found anything here and we have skipped a few packets because we missed it or whatever, we simply remove all the predicted packages. Remove all. And then we're going to say X timestamp is less or equal than our current timestamp from the data we received. I think this should work. Something like that. So this is a very basic implementation if this is going to work, and it will require more work to get it entirely done, but this will surely get you on your way. So let's fire it up. Ctrl B to compile. Hit play, and then we compile it again. Did it compile already? No. There we go. I was too fast again. Oh, come on. I'm forgetting it. I just simply need to run it here after compiling. So compile it once and then run it from your Explorer. Hit play and then start it on the server here on Unity, which will be the host. This will be a client. Let's move this over here. As you can see, it's really smooth on your own end. And then we're gonna add this one. There it goes. Now you can see it's jaggy, but this is really my networking, my video. So if you are probably doing this without video, it should be smoother, just as smooth as your local player. Okay, so now you can see it's lagging behind a little bit. So let's increase the speed here. So select the player. Let's move this over to 0.1, which is our lowest one. Let's set the correction threshold as well to like 1 unit. and then maybe hit Control B. Hit play. Run another instance here. Any instance on the server, in Unity, which will be the server. There we go. And now you can see it's actually moving. It's more responsive. You will always have this small amount of lag here. But this is really not noticeable when you're actually playing a game with somebody. I mean, you don't really notice it. I still have a feeling it's not really getting my send speed here, so I need to check this. Network send rate at 0.5, yeah. But I have a feeling it's not using it. Let's see. Backup manage send speed. Let's just check if this is. Should be okay, I guess. Let's debug this for a little minute. Packet manager, send speed. Let's try it again. Yeah, it says 0.1, so should be okay. And now you can see it's actually pretty fast comparing to the server C. So if I move this, yeah, well, yeah, I think this actually concludes this entire video for networking in an authoritative way with client-side prediction. There is still a lot of stuff you probably need to do to make this work for an actual game, or maybe for security, for performance, for whatever. But this hopefully gets you on the way in a different approach, which you might have seen previously on other channels or other tutorials. So I hope you enjoyed it. Please like and subscribe this video to this video on my channel for more content. Thank you very much. Take care.